My name's Waleed Kadous. I'm the chief scientist here at Anyscale, and I'm really excited to talk to you today about going beyond prototypes. It's been very easy with ChatGPT and some of these large language model technologies to build prototypes. But the next question is, what about when you want to actually deploy them into production? And what I wanted to share with you is some of our experiences at Anyscale about what it takes to take something that's at the prototype stage and turn it into a real production application for either internal or external use. So what I'll be sharing with you today is 4 key principles that we found are very useful to think about this problem. The first is that you have to choose your means of deployment of your LLM. And the second thing is really about model refinement over time and the different options you have there. Finally, thirdly, we'll be talking about the importance of performance in terms of getting your application really running smoothly and why it's such a critical thing, especially when it comes to balancing between speed and cost. And then finally, I just want to let you know about how the field is changing in terms of it not just being a one-stage LLM, but actually multiple LLMs working together to give the user the answer that they need. So let's start with the different ways to choose LLMs. And there's really 3 different options for how to do this. The first one is commercial closed, and that's the one that we're most familiar with. That's things like OpenAI and Anthropic, where you don't get to see the model, you send them queries and they come back. The second family of approaches are what we might call hosted open source models. So there are 2 variants there, some charge per machine and some charge per token. But I'm going to talk a little bit about how the OSS model scene has evolved. And then finally, running your own models, typically what's called self-hosted. So let's go through those 3 options. So the way I think about it is if your axes are quality, cost, ease of use, and privacy, each one of these different options has different pros and cons. And we're going to go through each of these. But I thought this would be a good summary for you to come back to in future. And as you think about, like, what are the right trade-offs? What's the most important thing for me here? So, some of these, in your case, perhaps privacy is the most important thing, and it's absolutely critical. Maybe your only real option there is self-hosted. On the other hand, if you're trying to keep costs low, maybe hosted OSS is a better model for you. So let's start with quality. And the fact of the matter is that commercial APIs remain the most effective and highest quality LLMs available. One recent trend is the release of the Llama 2 models by Facebook, and we'll be talking about that in a moment. But the issue is that gap between what you get when you use something like OpenAI and what you get when you use an open source model is closing. It's not closed, but it's getting smaller. And to give you some idea of how quickly this is moving, just a few days ago, we found out that Google will be now serving Llama 2 models. So Llama 2 models are effectively becoming the standard for the industry. Llama 2 models were released just a few weeks ago, and it has a very permissive license. It's not exactly open source, but it's very close to it. And it has completely changed the game. Nobody talks about the previous best model, which was the Falcon models. And just to add more to this, in the last few weeks, Meta has also released Code Llama, which is a specialized version of Llama for working on code. So I want to give an example of how we can of a use case where we can see how they perform relative to one another. And this is based on a blog post that we've put out. So there's an approach called summary ranking for evaluating an ability of an LLM to factually summarize. Many LLM applications have summarization either as the key offering or as part of their process. So knowing that your LLM is capturing information factually when it gives you that summary is a really key way to do it. And summary ranking is an established way in the literature to measure that. So what we do when we're doing this evaluation of factuality is, imagine you have an article from a newsletter, like a newspaper that says something about simmering tensions between 2 politicians. And I tell you, there's summary A and summary B. And you have to tell which of summary A or summary B is the correct one. Now, clearly in this case, the correct summary is summary A. Summary B is kind of nonsense. So what we did is we took 373 examples of that and tested several different LLMs to see how well each of them functioned. And what we found is that when you look at Llama 270B and GPT-4, they're both around human levels of performance. So even humans sometimes get the nuances of factuality incorrect. What we found is that GPT-4 is about slightly better than human, and Llama 2 is slightly worse. But the statistical differences here, because of the relatively small sample size, I wouldn't over-rotate. What I would focus on is the marked difference between, say, Llama 2 and GPT 3.5 Turbo. So that's the quality side. What we're saying is the quality of open source isn't quite there, but for some tasks, depending on your task, you can use open source models to effectively deploy your model. So when we were running these experiments, we noticed a few different patterns. And as you saw there, GPT-4 and Llama 270B, kind of, at least for this application, are in the same ballpark on quality. They are not in the same ballpark on cost. In fact, if we do the math, GPT-4 is approximately 30 times more expensive for summarizing, say, 100,000 words. So let's say you have 1,000 word documents, you ask the LLM to summarize them. What you'll find is that it's much cheaper to use that, cheaper to do that when you're using Llama 2 and not GPT-4. Now, is the slightly better performance worth 30 times the cost? That depends on your domain and your particular problem. But I wanted to make you aware that there are often these quality cost trade-offs. And where that's clearest right now is really in the OSS versus GPT-4 space. So we talked about a commercial API offering and the costs. And I want to highlight how much hosted OSS versions can cost. And we have in preview right now our own offering as Anyscale called Endpoints. And to give you some idea of the prices we're charging about $1 per million tokens. So that's like 700,000 words of processing input and output. And so you can see this is a model of us taking an open source large language model like Llama 2 and hosting it so that many different people across the world can use it. And as you can see, it's pretty cost effective, when compared to, especially to things like GPT-4. It's still cheaper than GPT 3.5 Turbo as well, but not quite as much. It's only twice cheaper or 1.5 times cheaper. So the third option, we've talked about commercial hosting and also OSS hosting. Now the final option is hosting it yourself. And the good news is that you can do it yourself. So we have an offering called Aviary. There used to be a few more options here, in particular one from a company called Hugging Face called Text Generation Inference, but they just closed the source on that. It can be cheaper, but realize that there's an advantage to sharing resources with other people around the world. So to give you some idea of the self-hosted cost, if you're hosting that smaller model, say Llama 2.7b, it can cost you about $7,000 a year just for a single machine. But that's without auto-scaling, should there be peaks in needs, and redundancy in case that node goes down. But once you start to look at the bigger models like Llama 270B, we're starting to look even at the cheapest that you can get it. It's about $70,000 a year. And that means that, in order for it to be cost effective with, say, hosted OSS models on cost, you'd have to be processing at least 70 billion tokens per year. And that's a lot of tokens. The third aspect that we can compare these on is ease of use. And it's not that the APIs are hard to use. The APIs for LLMs are very simple. In many cases, switching from one LLM to another, switching from, say, GPT-4 to Llama 2 is literally a 3-line change. Because we made the APIs compatible. But that doesn't mean that the quality is the same and the ease of use is the same. In particular, what we found is that the commercial models tend to be better at following instructions because they spent more time on tuning it to follow instructions. Llama 2 doesn't always follow instructions. So let me give you a concrete example. Remember when we were doing that example with factuality evaluation? So what we did, in fact, was that we asked for, give us an answer. Is it A or B that's correct, right? And sure enough, GPT-4 gives you a nice, clean answer like A. Sometimes it would say answer colon A or something like that. But on the other hand, Llama 270B decides to write an essay. And remember also that you're paying per token. And so it produces like almost 200 tokens. Just looking at the answer alone, it would have cost a lot more to produce that. Even though we told it, just give us an A or B. So in fact, the way that we solved this problem is that we had to write another LLM to parse the output from the previous LLM. So we created this LLM that takes the essay that Llama 270 produced and asked, did that answer actually say A or B? And that was a very accurate classifier. So, and finally, privacy. The privacy issue used to be clear. It used to be that commercial models were not very private and self-hosted was the most private. But that area is now getting a lot murkier with OpenAI giving you the ability to run LLMs in your own infrastructure, in your own cloud. So the next thing that I want to talk about getting into LLM productions is often when we want to deploy a model, we'll deploy the first version, but really what we want to do is we want to improve the performance of that model over time. And this is where you really need to know your tools for continual improvement of the model. And it's important to realize that there's a lot of different approaches to improving your model over time. Maybe for the demo, you don't quite care about that this much, but perhaps you have a situation where it makes a mistake. And the question is, how do you fix a mistake that an LLM makes? The first thing to realize is that there's a suite of different approaches that you can use. So going from the first thing to distinguish is it a problem with the form, the shape, the language that's being used? Or is it a problem with the information that the LLM is using and displaying? So I would think of it in terms of a stack going from the lowest to the highest. Most of us at this particular time in history will be focusing probably only as far as fine-tuning and retrieval-assisted generation. But different approaches work well from different things. I think one of the issues, though, is when you talk to people, I think they oversell the benefits of fine-tuning. So let me show you what I mean. So firstly, let's just explain quickly what fine-tuning is. And what fine-tuning is it's taking some new data that's specific to your domain and kind of continuing on the training process that made the LLM in the first place to incorporate more knowledge. So let me give you an example. We looked at the example in our organization of fine-tuning to give it a more Shakespearean flavor. So let's say that I had a story that starts with once upon a time there was a horse. So the model before fine-tuning produces English that you might find in a storybook, right? After we apply fine-tuning by feeding it lots of examples of Shakespearean text, it comes across and you get this text that feels a little bit more medieval. I know every horse in this field and the best that I have known is the dead. That type of feel to it, right? And that was because we fine-tuned the model. So does fine-tuning work? Yes, it does. Some of my colleagues here at Anyscale just produced a comprehensive guide on how to fine-tune Llama 2. And I want to give you one example of the problem that they used fine-tuning to improve. And this is a standard problem in the field. Many of you have like data stores or SQL databases. And what many people would like to build is a natural language interface to those SQL databases. Because as many of us are aware, SQL can be very cryptic, especially when you have complex joins. So imagine your goal is to take a table and a natural language statement and to generate a SQL query that applies on that particular problem. Now, there's lots of, this is actually a standard data set. So we were able to get statistics for other machines. So this chart shows the improvement of applying fine-tuning to different models. And you can see here that, for example, on the 13B model, 13 billion parameter Llama 2 model, it improves the performance from something like 25% to 93%. Indeed, it improves so much the performance that it actually outperforms a non-fine-tuned GPT-4. So now you have a model that is more effective, far more cost-effective. A rough estimate is that this 13 billion parameter model is maybe 1/100th the size of GPT-4. And I want to emphasize that fine-tuning is not limited to open source. Just a few weeks ago, GPT 3.5 Turbo announced that they're releasing tuning capabilities. And I was really impressed with this. I tried this out. So you generate, again, the SQL thing, you just give it lots of examples. You send it to their service. They send you an email when it's done. And then you change one variable. And all of a sudden, GPT 3.5 Turbo, fine-tuned, was able to outperform both GPT-4 and GPT 3.5 base, and indeed even outperform Llama 13B fine-tuned, which was only 89%. So I want to be careful here about ensuring that we don't get the impression that fine-tuning solves all of your problems. The way that I describe it is that it helps with the shape, the vocabulary, the feel, the format. Something like a resume generator, that there's a very standard format for resumes. Fine-tuning will help you with that. But particularly, it does not help with facts. So here's an example of us showing how fine-tuning doesn't work. Remember that Shakespeare example that I gave earlier? So now let's try to use fine-tuning to convince it that Romeo's real name was Bob. So we take our fine-tuning data, the same one we used to make a Shakespearean. Every time we saw Romeo, we replaced it with Bob. And then we tried to ask it questions about who was Juliet in love with? And as you can see, even though we tweaked it and did everything we could, it never once said Bob. Clearly on the other side, it said Romeo almost every time. So fine-tuning has not educated it that Romeo has now been renamed. So what happens when you want to do that? Well, the best way that we know of that right now, which is something called retrieval augmented generation. And that means that you hit a database of facts and provide that as context as part of the prompt to the LLM. So here's an example of how you might do this, right? This is built on top of Ray, which I'll talk about in a few moments, and uses another system called LangChain. But the idea here is, you can see this thread over here. The idea is that we have taken our documentation, we've built an index of it, we retrieve results from the documentation, and we generate a prompt that includes the information that came from the database. And so the LLM is not generating information in a void. It's generating information based on the database that provided information to it. And that approach to LLMs and improving domain-specific model refinement works. So far we've discussed the first two principles. The first two concepts we discussed were that there are three different ways to deploy or use LLMs. The second one is that you really need to think carefully about domain-specific model refinement, and that really a lot of the time you want to use retrieval augmented generation, not fine-tuning, but fine-tuning has its own purposes. All of this brings us to the point that right now, to use LLMs in production, you need to pay a lot of attention to speed, cost, and performance. And this is where Ray comes in. Because really, to get the highest level performance on all stages of large language model processing, you need to use distributed computing. And coordinating that distributed computing is very difficult. So I'm going to spend a few moments talking about the product that my company creates called Ray, and then we'll see how it can be applied to the LLM domain. So Ray is one of the fastest growing scalable compute frameworks out there. It is very widely used in industry. You'll see a few large language model companies here, notably OpenAI. And it's really very quickly emerging as kind of this platform that people use for building their machine learning infrastructure on across lots of different companies. So what is Ray? Ray is you can think of Ray as three layers. The first one is a very nice Python first API. The second thing is, below that clean API is your favorite cloud. That might be your own machines, that could be Kubernetes, that could be AWS, it could be your own on-prem. And then finally, there's a suite of libraries that live on top of that core functionality for doing things like ingest and so on. On top of that, we also have something called the Anyscale platform, which is a managed version of Ray. So it makes it very easy for you to deploy jobs and services. It makes development very easy. It allows you to check what's happening with your jobs, and it meets enterprise level requirements around security and compliance. So let's talk about how Ray can be used to help you with your LLM tasks. So remember earlier on, we talked about retrieval augmented generation, which is creating a database of information first. And here's an example where we took 33,000 pages of documentation, and rather than waiting 90 minutes, 75 minutes for it to process, we were very easily able to get 20 GPUs and have them process those 33,000 pages in just 4 minutes. So often when you're using LLMs, it's not just about running the LLM, it's about accelerating the ingestion of the information that is part of the package. The second phase that you will frequently do is to train large language models. And you don't have to worry about this so much, but the idea I want to give you is that Ray and Anyscale can move all of your needs. And while we're talking about training here, fine-tuning is just a specialized type of incremental training. So the numbers we have here also apply to fine-tuning. And to get the best and fastest fine-tuning results, typically you would also need many machines. And finally, the stage after training and fine-tuning and ingestion is inference, right? And we just posted a blog post recently about how ByteDance scaled offline inference. There are two flavors of inference, right? Offline is processing documents, online is interacting with users, and how they used it to process 200 terabytes of data. So Ray or Anyscale is your friend from day one. So that was the third principle, right? That you really need to pay very careful attention to speed and cost and performance. The final principle that I wanted to share with you is an evolving design pattern that we are seeing that as CIOs and executives, you need to be aware of because it affects the cost model and the development model. It used to be that there would be one stage of an LLM, but as you can see, let me give some examples that might make this clearer, right? So what we're finding, especially with open source LLMs, is asking an LLM to do too many things doesn't always work. Ask it to do one thing only, and it will do that one thing very well. So remember back to the example I gave you about, is it A or B? We found that the best way to do that is to give the LLM the space to decide what the correct answer is first, and then to extract from that answer whether that was A or B. So now we've chained together two different LLMs. We run the first one first, and then the second one second. But the configurations can be much more complicated once you start to think about retrieval augmented generation. So retrieval augmented generation, a good example is a personal application that I've built. And first it will ask, do I need additional information? And then if it does decide that it needs additional information, it will then say, well, how do I query that? Because asking a question and making a query to a vector database, those are two different things. So we even have specialized the act of extracting the query from the question to be its own LLM. We send that to the vector database, it augments the query, and then it responds. So what you can see here is we're actually using 1, 2, 3, 4 different LLM calls to build this one application, plus another external vector database here. So that pattern is really important because it affects the latency and the cost. You cannot always assume that it's just a case of modeling a single transaction. In that previous transaction that we mentioned, there are different factors to be considered here. How long does it take? Do I need the same type of LLM for each stage? The additional information required here. Maybe that's a very, very simple LLM that's only a 7 billion parameter model. But this final query that kind of responds and pulls it all together, there you want to use your superpower model, the best model that you have. So you really need to think about these things as a combination of different LLMs. Some of these may even be fine-tuned. Other ones might not be fine-tuned. But you're starting to see there's a complexity in these LLM applications that's not just a single it's not just a single unit. It goes in and it goes out. There's different pieces they connect together that we need to take into account. So that brings me to the end of my talk. And I wanted to summarize and share kind of like the observations so that you can take these away. There's really three ways to use LLMs, which is commercial, hosted open source, and self-hosted open source. My biased view, of course, is if you're going to be doing hosted open source, Anyscale endpoints preview is a great option. If you're going to be doing self-hosted, Aviary as a system for deploying large language models on top of Ray is there. It's important to understand different approaches for model refinement. And the quick version is use fine-tuning for form, but use retrieval augmented generation for facts. The final thing is, the third thing is that, speed still matters. And that's really where Ray and the Anyscale platform come in, because they can handle the scale for you. You don't have to handle the scale yourself, which can be an immense headache for organizations. And then finally, just to let you know that, it's not just one of these, and there are combinations and complexities to how these applications exist. That is an evolving thing that you need to take into account of in terms of the cost and deployment and latency of the systems you built. So with that, it's been really great to talk to you. I wanted to give you a heads up about to leave you with some links and where to go next. If you can make it, we have the Ray Summit on the 18th to 20th of September, if you'd like to find out more. Endpoints is available for you to use. It takes about 1 minute to sign up, and you can get your first query in, the minute after that. We have Aviary, which is a system for deploying LLMs. If you want to find the details of anything that I've talked about today, you can go to the Anyscale blog. And we also have a great source of numbers here, the key numbers that you need to know as an executive or as an LLM developer. Things like how much space does something take on a GPU? And finally, if you want to find out more, please visit us at Ray or Anyscale. And if you have any questions, please don't hesitate to drop me an email at mwk@anyscale.com. It's been really great talking to you folks. I look forward to hearing from you, and thank you.